The problem name is Pascal's triangle. Given an integer number of rows, return the first number of rows of Pascal triangle. In Pascal triangle, each number is the sum of two numbers directly above it as shown. So we can get the number here by adding the above two numbers. Here we can see 4 is came by adding 1 plus 3 here. Here we get 2 by adding 1 plus 1. In this way we are going to generate this Pascal triangle. So we will be given the number of rows. We need to return this entire Pascal triangle in the list of list form or else a vector of vector end form. So let us see how to generate this Pascal triangle. So in the example 1 we see that input as number of rows is equal to 5. So in order to generate this Pascal triangle, we will assume this 0 for we will assume this 0 as the right hand and as the left hand, and instead of 1 we will be assuming 0 as the right hand and left hand. Now to in order to generate second row we will be adding 0 1 plus 0. Here it will be 1. And next we come to let us say this is 0, this is let us say that this is 0 index and this is 1th index, and now here when we add 1 plus 0 we get as 1 here, 1 plus 0 here it is 1. Now again we go to 0th index and we add left side value, which is we are assuming this 0 to be on the left side. When we add 0 plus 1 we get as 1, and to generate the third row we will be using the previous row in order to generate the third row. So we will be starting from here onwards. So from 0 1 2, these are the indexes. Now let us see, from 0 we are starting. Here 0 plus 1 it is 1. So now 1 plus 1 it is 2. Now 0 plus 1 and it is 1. Here at the end we assume 0. Now we again start doing this. 1 plus 2 no, 0 plus 1 which is 1. 1 plus 2 3. 2 plus 1 3. 1 plus 0 1. And we keep again 0 at the last. Now 0 plus 1, as I said here this is already done. Now we again start looping till the previous length elements. So previous length is of 3. Okay, this is already completed. Now we add 0 plus 1 1. 1 plus 3 4. 3 plus 3 6. 3 plus 1 4. 1 plus 0 1, and at the last we keep at 0. So these 0 values are in the assumption, they are not kept in the answer. So how if we assume 0 is present in our answer array, we will be doing like this. Nums of I will be starting from this index and this number, and we add the previous number, that will become the current number. So in that way it is going to give the value of the bottom one. Now we are assuming 0 as our left and this 0 as our rightmost element, right? So when we this is the previous array length. Suppose this will be array, right, in the answer. So in the answer this will be in the array format, 1 2 1. So in this way we are going to return, right? So I'll be writing here 1 comma 1 1 2 1 1 3 3 1 1 4 6 4 1. So in this way we are going to return in the answer. So to remove zeros or else to ignore zeros, we first check this n is the previous. Suppose we are constructing this row. Suppose let us say we are constructing this row. For the constructing this row, what we use the previous row, right? So I will be starting from 0 1 2. So we assuming 0 as or towards the right. We travel till the second element, till the length of the array. So this how much is this length? This length will be 2, right? So we travel till 2. So when I double is equal to length of the previous element, we assume it as 0. So this is the ternary operator. So we assume it as 0. If it is not the previous length, then we keep it as nums of I. In this way, we handle this condition by adding the adding the current and previous element like this in order to generate the bottom number. So when there is also one edge case here, when we are at 0, at we need to add previous element, right? So previous element will be 0 here. So but I minus 1 gives the out of bounds case, right? So for that I will handle when I minus 1 is equal to minus 1. That means this index is minus 1, right? If this is 0, so if that is minus 1, I keep it as 0. Otherwise I use the if I am here, if the I is here, I keep it I use the I minus 1 because this will be in the correct range. So in that way we are going to add the current and previous element and pushing it to the next array. So let us code this. So for returning the answer, we first initialize answer with 1. Next, our row generation will be starting from the second in. So row will be starting from 2 and rows and rows need to be generated till number of rows, right? So till the number of rows we need to generate the Pascal triangle. Now here what I have said, I will be using previous array. So this previous array is going to get traveled till the length of the array. So this length is 1, right? So till the length of the array we need to travel. So what is the length? It will be taken. So answer of row minus 1. Answer of row minus 1 dot size. This gives the previous row size. Now we need to travel till the previous row size. I is equal to 0, I less than or is equal to n, I plus plus. We need to travel till the end of the previous row. When now to generate the bottom value, that is to generate this value, we need to add the current row element and the previous row. So in order to add that, we check the conditions whether I double if the I is equal to 1, that means suppose if the I is equal to n, that means we need to assume it as 0. Otherwise we need to keep the previous row. That is we need to keep the previous row value, that is answer of previous row. I will use the previous row, a variable here, previous row. is equal to row minus 1. So this will be the previous row. Now I will use this variable instead of writing always row minus 1. So now, so no, we need to no, we should use the I variable. Sorry. Okay, we should use the I variable. Now if the I minus 1, if I minus 1 is equal to minus 1, that means we are at the 0th index. We are at the 0th index, we will be placing 0. If we are not at the 0th index, the left side element will be nums of answer of. Okay, we will be using previous row, right? Okay, previous row and I plus we need to add the previous element. Suppose we are at here, I will be adding this one element and the previous element. So I checked this condition. When I am at nth position, I should assume it as 0. When I is equal to n, I should assume this as 0. Otherwise, I will assuming the ith element. That is, if I am here, suppose I will be assuming this element in the previous row. Suppose I am constructing this, I will be assuming this. In the previous row, we need to check that. So when I double is equal to 0, that means no, when I minus 1 is equal to minus 1. So this is the case where I is equal to 0 and I minus 1. It will be 0, right? And this index will be minus 1, right? So when we hit that case, we should assume 0. Otherwise, answer of previous row and I minus 1 we should use. Now we have generated the bottom value. Suppose this name is as bottom. Okay, so that is the x is the bottom value. Now in the next, so suppose let us use one array. This is the temporary array that we need to push it to the answer. So this temporary array, we should push this value, this x value, and we should push this answer. We should push this temporary array to the answer. So we'll be returning answer at the final. So here initially the row initially there is a one row, and we'll be constructing rows from second row onwards until the number of rows, and the previous row is row minus 1. It will be the previous row, that is the previous row, and we should take the size of the previous row. So previous row size is taken. Now we will be generating the a temporary array, that is we generate this middle arrays like in the answer. This is, I am assuming this as temporary array, and I will be starting from 0 to till n. So there is less than or is equal to, till n we need to travel, that is 1 till 1. Suppose we are constructing second row, till 1 we should travel, and if the I is equal to 1, so I is equal to n means we have reached the nth condition. We should assume it as 0, and if that is not, we should directly use the previous row ith element. And if the if we are at a 0th index, we will be encountering I minus 1 as minus 1. When that case occurs, we should assume it as 0. Otherwise it will be of I minus 1. Previous rows I minus 1. So here I have added a, a extra brackets because the ternary operators is from right to left. So that's why I have added this extra brackets. Otherwise the output will be wrong. And we will be pushing the current bottom element that we have generated, and we push it to the temporary array, and we push that temporary array at the final completion of the generation, and we will be returning the answer. And this time complexity will be of uh, so uh, so till the number of rows into how much number it can generate of at most 1 2 3 4 5 numbers will be generated, right? So this will be of time complexity n into n. So time complexity will be of n, number of rows, so n into n, it will be okay, it will be number of rows. And the space complexity that we are using this temporary array for storing the answer purpose. So time complexity will be O of n, but this is for answer, so this will be ignored. Like the space complexity cannot be considered here because this is for storing the answer purpose. So let me run this code. So we are getting error. So here I have made a mistake. Here you need to consider starting from one. Like here 0 is the first row, right? So here I started from second index, but the second is out of bounds case. So here we got error for that purpose. So now I am keeping it as 1. So now the correct output will be generated because previous row will be of 0. Here okay, till the number of rows minus 1. Okay, because we are using 0 based indexing for generating the answer. Here also we can see that it generated one more extra row, so we will be starting from 0 till number of rows. So that's my mistake. So now the result will be correct because we are starting from 0th element, so we will be reducing one number, and row will be starting from 1. So this one is acting as 2 because we are using 0 based indexing. So let me return the output. So this will be working for the edge case also. If there is only one element, so if there is only one number of rows is passed, then the output is also going to generate because we are initializing the answer as 1 initially. So let us check that input also. So we can see that we are generating 1. So now let me submit. So we can see that our code is worked. Time complexity will be O of n square and space complexity is O of 1. And thank you.